In this video, we are looking at example 3 on the notes over modeling with trigonometric functions. And this is one of my favorite types of problems. I like doing these Ferris wheel problems, so I hope you enjoy it too. It says a Ferris wheel has a radius of 20 feet and the bottom of the wheel is 10 feet off the ground. It's going to move counterclockwise and it takes 8 minutes to complete a full rotation. So the first thing that they ask us to do is to create a table that shows the height of the rider off the ground at certain times. And these are, you'll see in just a minute that these are kind of key, easy times to find the height off of the ground. And it's going to be enough for us to sketch the graph, which is what we're going to have to do with that next. So the first thing we want to do is really draw a picture of what this Ferris wheel looks like. So the Ferris wheel, it says, has a radius of 20 feet. So let's kind of draw something that will represent a Ferris wheel. And it says that the bottom of the wheel, which is right here, is 10 feet off the ground. So let's just kind of draw the ground right here. And here's the bottom of the Ferris wheel being 10 feet off the ground. Here's maybe the legs of the Ferris wheel. And then we know that the radius of this is 20 feet. So distance from here to here is 20. And then, of course, up to here is also 20. So we have a person who gets on the Ferris wheel. We presume that they get on at the bottom of the Ferris wheel. And it says that they're going to move counterclockwise, like this, and that it takes 8 minutes to go all the way around this full rotation. So if you think about that, that means that they will be a quarter of the way right here at 2 minutes. They'll be up at the top at 4 minutes, so we're assuming that it moves at a constant rate. Over here at 6 minutes, and then back down to the bottom at 8 minutes. So the bottom, of course, is both 0 minutes and 8 minutes. All right, so now we want to think about, at each of those places, how high is the rider off the ground? And we're going to make a table about that. So we'll have time here. Let's do T for time, and H for height. So the time, let's define our variables here. T equals time in minutes. And H is going to be the height in feet off the ground. So we're going to do the times 0, 2, 4, 6, and 8. And then the height. All right, so at time 0, it means I'm at the beginning. So my height off the ground is 10 feet because that's what we were told at the beginning. At time 2, which is right here, we're this distance off the ground. Well, notice that that distance is the same as this distance right here, which is 20 plus 10, which is 30. When I'm up here at the top, all right, now I can see that that distance is the 20 plus the 20 that we had plus 10, and so that it turns out to be 50. When I'm at 6 minutes, all right, then I can see that I'm back here where this distance is the same as this, which is 30, and then at 8 minutes, I'm back here at 10. All right, so now what we want to do is sketch a picture of what that looks like. And all of my heights are positive, so I can put my x-axis a little bit towards the bottom. And so we want to plot, first of all, our time values. So this is time in minutes. And we're going to go from 0 to 8, and we'll count by 2s. So we have 2, 4, 6, 8. And then the heights, we have 10, 30, 50, and 10, 30, and 50. And it doesn't have to be perfectly drawn to scale. We'll just kind of put those three numbers here. 10, 30, and 50, and remember that this stands for height in feet. So this is our Ferris wheel graph. All right, so now we're going to graph these points. So we have 0, 10, 230, 450, 630, and 810. And when you look at those, you know, you may say, well, I don't know exactly what the shape is going to be, if it's going to be curved or if it's going to be straight line segments. And if we put in some other values, you know, if we went in here and measured, well, what about at 1 minute? How high is it off the ground? And did some calculations and put in some more points, we would find that this is going to be sinusoidal. So the graph can look like that. And then it continues on. If I continue on with another rotation around the Ferris wheel, then I would just get a repeat of that kind of chunk. All right, so then we're going to be asked some questions about this particular problem. All right, so this one says that we're going to write a sine function, and you'll notice down here that after we write the sine function, we're going to practice writing a different one. We're going to write a cosine function. So remember that the period stays the same no matter what repetitive chunk you take. B, of course, then, because that depends on period, will stay the same. Maximum height, minimum height, amplitude, equation of the principal axis, your vertical shift. All of those don't matter whether you're doing a sine function or a cosine function. They're all going to be the same. The only thing that's going to change once you change the function is what your phase shift is, and we'll talk about that. So the period. So what does it take to go through one cycle? Well, we can see that this is one cycle, and so the horizontal distance that it takes to do that is 8. For B, remember that the formula is that B is equal to 2 pi divided by the period. So it's 2 pi divided by 8, which simplifies to pi divided by 4. So that's going to be our coefficient of B that's going to go in here in front. The maximum height we can see is 50. The minimum height is 30. And so that tells us that the amplitude, which is the maximum minus the minimum divided by 2, is 20 divided by 2, which is 10. No, I'm sorry. 50 minus 10 divided by 2. So that's 40 divided by 2, which is 20. The equation of the principal axis, remember, is the, back here, I wrote the wrong value here. Sorry, minimum height is 10. So the equation of the principal axis then, remember, is the average of the high and the low. So that's 50 plus 10 divided by 2. So 60 divided by 2 is 30. So that tells us that the vertical shift, because the equation of the principal axis is now y equals 30, the vertical shift is up 30. So that's, we can just say 30. Okay, so now we are at the phase shift, and we said that depends on whether we're doing sine or cosine. So if I'm going to do the sine graph, then what I want to choose is something that looks like the parent function for sine, which starts in the middle on the principal axis, goes up, and then down, and then back to the principal axis. So we know that the principal axis is right here. That's our y equals 30. And because our sine function starts right here on the principal axis, if we come across here, this would be a good starting point for a period which stands for the sine function. So it's going up, coming back down again. I picked that. And then we presume that it's going to continue on like this. So we can kind of take that piece of it. So remember what I said to do with this then is to draw the principal axis, draw a vertical line through the starting point of that cycle that you've chosen, and that's the image of the origin. The origin used to be here for the parent function, but it's moved over 2 and up 30. This is the point 230. So what that tells me is that my phase shift, my horizontal shift, is 2, the positive meaning that it's going to the right. And so if I write this equation then, filling in all the values here in the sine function, first of all, we know that that's related to the amplitude, and because this is a sine function that's first going up, then we know that that's going to be positive. So this will be positive y equals, everything is freezing here. It's going to be y equals 30 times, remember I'm writing a sine function, so sine of b, and we just figured out that b is equal to pi over 4, so we get pi over 4, times the quantity x minus c, but c is this phase shift, the horizontal shift, so that's c, and then plus the value of d, which we calculated is 30. Remember this is d also, 30, not 3. My amplitude was 20. There we go. All right, so then you can check that on your calculator and just make sure that that works. All right, so now it says to write a cosine function. So let's go back here. So if I want to write a cosine function, I need to choose a piece that looks like the parent function for cosine, which does this. And so the cosine function, let's pick it green here. Probably a good piece would be to pick this piece right here, because that looks like a positive cosine function. And so if we want to do that, we again just draw the principal axis, which we already have, and then a vertical line through the starting point of that period, which is here, right? And that point where those intersect is the image of the origin this time. And so that point right there is the point 430. So now if I write the cosine equation, then it's going to be y equals A. A is the amplitude again, and this is a right side up cosine graph, so it's 20 cosine of B, which is still pi over 4, times the quantity x minus 4, right? We're going over 4 and up 30, and then plus the value of D, which is 30. So we end up with negative cosine of pi over 4 times x minus 4 plus 30. So that's one possible option. You could also do the upside down cosine, which is right here, and then that wouldn't have a horizontal shift at all. And so you could also do y equal, but it's upside down, isn't it? So y would be equal to negative 20 cosine of pi over 4x, because this value would just be 0 right here, and then plus 30. And I would invite you to try those out on your calculator and convince yourself that they work. The last one, the U-try problem, I will just write that one up and post a complete answer key for that.